Hello good people and welcome back to another math video. This one is going to be on the area of composite figures, and this is the first video in the series. So if you're looking to learn about composite figures in their area, you should start with this one. Alright, let's get started. So first off, just a little definition. A composite figure is a figure that is composed or made up of more than one shape. What does that mean? Well, here's a regular rectangle. It's not a great rectangle, but here's a regular rectangle. This is just one shape. So if you wanted to find the area of that shape, you could just plug your area formula in, base times height, and you would figure this out. No problem. When we have a composed figure, we have a shape that might look something like this. And now it's made up of more than one shape. You can sort of see the obvious rectangle part here, but then there's also this other shape down here that isn't really part of the rectangle, but it's stuck on there. And there's many different ways that a composite figure could be drawn, but the big takeaway is that you can't just do a normal area formula to solve for it because it's made up of more than one shape. Here are a few composite figures. And again, like I said, there's many different ways these could be drawn. The biggest thing, and really the first step when you're trying to solve the area of a composite figure, is to see it as more than one shape. So I'm going to draw some dotted lines on these shapes to show you how I would see them. So this first one, right here, I would see this as a rectangle and a triangle. So I might draw a dotted line right there. And then if I knew the dimensions of this rectangle now that I've made, I could call that sort of like shape number 1 and figure out the area of that rectangle. And this triangle over here, this would be shape number 2, and I could figure out the area of that one. This next shape right here, well, let's see. I think I would imagine this as a square with a half circle on top. So if I could solve the area of the square first and then solve the area of the half circle second, I could put those together and that would tell me the area of the whole shape. Down here to this symbol that looks kind of like a plus sign, I might see this as 3 shapes. If I did some dotted lines here, then I kind of have a rectangle right here, and then I have one square here and another square here. So I could solve for the area of the rectangle first. That would be sort of like my shape number 1. Then I could solve for the area of this square. Then I could solve for the area of this square. And if I added all those together at the end, that would tell me the area of that entire plus symbol sort of shape. Sometimes we get a composite figure like this one, where it's not like it has a little part sticking off the side of it, like some of these other ones, but it's actually kind of missing something. Now this, we still need to see this as 2 shapes, but the approach is going to be a little bit different. For this one, I would draw my dotted line here, and I would see this as one large rectangle right here that's kind of missing a triangle part. So to solve this one, I would figure out the area of the whole rectangle, then I would figure out the area of that little triangle part, and I would subtract the area of the triangle from the area of the whole rectangle, and that would give me the area of just this part. Let's get started on a couple examples. In problem number 1, we have this composite figure that looks a lot like a normal rectangle, but it has a little part sticking out on the bottom. So again, the first step is always to see this as 2 shapes. There's more than one way to do it, but I would break it up like this. And the reason for that is, now I have this shape down here that is one side of 2 and another side of 2. That's a square. So this is going to be really easy to solve. Sorry, let me toss some units in here for you. We'll do meters. Okay, so I'm going to call that little square my shape number 1. And then I'm going to call the leftover rectangle here shape number 2. So I'll solve for shape number 1 first. And that's going to be area is equal to base times height. So the area is going to be equal to 2 times 2. So the area for number 1, the shape number 1, is going to be 4 meters squared. Done. So now we can move on to shape number 2. It's a rectangle, so it's also going to be base times height. All right, well, here's the base, 10, so that's pretty simple. So let me put that in. And now I just need the height. Ooh, slow down. Here's a little trick. I don't know the height. And the reason that I don't know the height is this 8 right here, that is the length of this whole side. It is not the length of the new little rectangle you created when you did your dotted line here. So basically, we need to figure out what is the height of this rectangle. Well, you have enough information to figure that out. If the whole thing on this side is 8, and I know, because of this 2 right here, I know this little part down here is 2. Let's see, the whole thing is 8, and the little part is 2. So I could take the 2 part away, and that would tell me that this section is 6. So now that I know that that height is 6, I can put that in over here. 10 times 6 is 60 meters squared. So I can just add the area of my first shape to the area of my second shape. 60 plus 4 is 64. So I know the area of the total shape is 64 meters squared. Here's our second shape, our second composite figure. Again, that first step is going to be to break this up into more than one shape so that you can find the area of each individual shape. And when I look at this, I see it breaking up rather nicely right here. And if I do that, then I'm looking at a nice, easy rectangle for shape number 1 and a triangle for my shape number 2. So let's get started. So the area of shape number 1, that's our rectangle. So I can put in my formula. Area is equal to base times height. I know my base, that's 8. And I know my height, that's 12. And if I multiply 8 times 12, I get 96. And again, those were meters, so 96 meters squared. That's my area for shape number 1. Shape number 2. Well, shape number 2 is a triangle, so I have to use the triangle formula. You could either do base times height over 2 or 1/2 base times height. Either one. Now, if I look at this triangle, it doesn't have a base clearly written in it. And where I'm looking is, right here. There's no base written right here. But I can see that the base for that triangle is really the same as the base for this rectangle. So I know that the base of that triangle is 8. So I can put that in. Now, the height of the triangle is given. That's right here. That's given as 4. So now I have all the pieces, and I just need to multiply. Remember, multiplication is commutative, so the order doesn't matter. You could multiply this in any order you want. In my mind, the easiest way to do this would be to multiply the 1/2 times the 8 first. Half of 8 is 4. So I know that those two are going to be equal to 4. And then I still have the other 4 to multiply. And 4 times 4 is, of course, 16. I'm working in meters, so this is meters squared. So the area of shape number 2 is 16 meters squared. So to find the area of the total shape, I just would need to add 96 plus 16, and that equals 112. So the area of the total shape is 112 meters squared. Okay, here's a little recap. So step one, when you're working with composite figures and trying to figure out their areas, it's really to see more than one shape. So when you have a shape that looks like this, or when you have a shape that looks like this, or when you have a shape that looks like this, you want to see this as more than one shape and think about, where can I break this up so that I can figure out the areas of each of the parts and then combine them. And so that really brings us to our step 2, which is to solve for the area of each shape. And the last part, step 3, is to add the areas for the total area. Okay. Well, that's it. There's a little intro to composite figures. Our next video will also have some composite figures, but we'll dive a little deeper into some of those more missing section composite figures. Hope you have a great day, and we'll talk to you soon.